Okay, so battery issue solved. All right, so just to review, so we're trying to prove that this formula is true. 1 plus 3 plus 5 plus 7 up to 2n minus 1. That sum is equal to n squared. We're using a technique called induction where we check it's true in the beginning. So we checked it for n equals 1, 2, and 3, so that's good. We assume it's true up to some number, k, and that would mean that 1 plus 3 plus 5 plus 7 up to 2k minus 1 is k squared.
Yeah, now we're trying to check it for like...
Now we're trying to show that if it's true for k, it's true for k plus 1. So that means if it's true for k plus 1, that 1 plus 3 plus 5 plus 7 plus 2k minus 1 plus 2k plus 1 should be k plus 1 squared.
Alright.
Well,
Okay, so what do you think we should do?
So we know that this part of it equals k squared.
Okay. All right, so I'm gonna have to sort of erase up here. Right. So we know this part up to here is k squared. So now I've just got k squared plus 2k plus 1, and we're trying to show, does this equal k plus 1 squared? What do you think?
Let's see, so I think it does. So you can just see what k plus 1 squared is. So you get k squared first.
So this is k plus 1 times k plus 1.
So you get, first you get k squared.
K squared.
And then you get k times 1, that's 2k. And 1 times 1 is 1, it's plus 1, so it's exactly what we got here.
It's exactly what we got here.
So that shows it's true.
That shows it's true. So now we have checked in the beginning. If we assume it's true up to k, then we know it's true for k plus 1. So in other words, if we know it's true for one number and k, we know it's true for the next number.
And then it's true for the next and the next and the next.
So it's true for all numbers.
So it's true for all numbers. So
Nice.
the sum of the odd integers up to 2n minus 1 is n squared.
N squared, nice.
That's how induction works. Okay, so now what we're going to do off camera, we're going to build some geometric representations of these numbers, the regular numbers, the triangular numbers, the square numbers, and then the pentagonal numbers, and we're going to see what we find, okay?
Alright.
Alright, so we'll do that off camera and then we'll talk about them. We'll do it with our sum set.